Today, I will be introducing you to the technical aspects of our MagicPower product. We will explore the key features, design, and technology that set our products apart. This section will cover essential functionalities and some tips to help you get the most out of MagicPower solutions. Thank you, everyone, for joining us today. The content of this presentation covers three distinct types of energy storage solutions. The first one is portable power stations. Okay. Basically, these are compact mobile units that provide temporary power for various outdoor applications. The second one is residential energy storage system. These systems are designed for home use, allowing homeowners to store energy for later use. And the third one is commercial and industrial energy storage systems. These are large-scale systems caters to businesses and industrial applications. Each type of application, each type of energy storage solution has its own unique features and applications. Okay, so we will move to the first one, which is a portable power station. Basically, the series for portable power stations called PowerPal. Basically, these systems are ideal for off-grid situation and emergencies. These stations features multiple output ports, enabling you to charge the various devices such as smartphones, laptops, and small appliances efficiently. The PowerPal series is perfect for outdoor adventures, emergency situations, and remote work scenarios. So, if you look at the key features of the system, so the system is available in various power capacities and rated output powers. It features in bidirectional fast charging, which make it fully charged within 2 hours. The system includes a smart app for easy monitoring of the battery status at a glance, and we can somehow control our system from the applications. The system ensures safe electricity usage with the battery management system. Okay, that's called BMS, battery management system. And the system is equipped with an intelligent temperature control cooling fans for efficient and safe heat dissipation. So next we will look at the specification of the Power Pulse series. The rated output power for the Power Pulse series, so there are three types. The one is a PowerPower 1000, 1500, and 2200. For PowerPower 1000 and 1500, the rated output power is 1500 watt, while for 2200 it's 2400 watts. Basically, this is a continuous and peak power ratings. Okay, the battery capacity for PowerPower 1000 it's 1024 watt hour, for 1500 it's 1536 watt hour, and for 2200 it's 2160 watt hour. If we talk about the cell technology for this system, so it's a lithium ion batteries and charging mode of the system. Okay, it can be charged via AC or DC. Okay, if we look at the charging, AC charging, so PowerPower 1000 and 1500. So the maximum input power from the power grid it takes it's 800 watt, while for PowerPower 2200 it's 1200 watt. And if you look at the DC charging, with the solar panels or some adapters, but here we will look at the solar panels charging method. So for power 1000 and 1500, the maximum solar power we can connect is 400 watt, while for 2200 it's 600 watts. Input and output voltages and frequency for on-grid and backup side. So the system is single phase, so it could be either 220, 30, or 240. That's depend on the grid standard and the appliances you are using. And the frequency it is selectable, either it is 50 hertz or 60 hertz. Input and output ports, so the systems come with IC outlets for charging and for the load. Okay, in case of DC ports for charging and for the load side. Life cycle of the batteries. So in this case, the life cycle for the battery number of life cycle is 3000, but it should be at 80% of depth of discharge. So basically, one cycle we consider charging from 0% to 100% and discharging from 100% to 0%. But in case of 80%, so it's from 20% to 100% charging and discharging from 100% to 80%. If you look at the safety features of the system, the protection, so which is higher low temperature, over and under voltages, overload protection, and short circuit and overcurrent protections. So next we will learn about the product appearance. Okay, so here we can see the front view of the products. The LED display displays some information about the battery percentage, the load connected to the system. Okay, the time remaining, if there is any alarm or like warning or fault in the system, so it will represent here. Here we can see the solar charging or DC charging method, direct DC from adapter, the solar panel charging ports, DC outputs, so direct DC outputs, and here we can see type A and type C. In the AC outputs, we can see there are two outlets for the AC. These are the AC and DC outputs are controlled via button for we can turn on and off this outputs. If you look at the back view of the system, so there is an LED and it's come with a LED button. On the side view of the system, there are cooling fans are installed for heat dissipation, and there is an AC input for charging through power grid. Okay, the second one is residential energy storage system. So there are two kinds, the low voltage and high voltage. The low voltage operates at a single phase, okay, which is ideal for homes with lower energy needs. And if we talk about the high voltage energy storage system, so these systems utilize three-phase power, these are suitable for large homes or those with a higher energy demands. So first we will learn about the low voltage energy storage system. Okay, the series called Helios series. So the rated output power for the system are 6 kilowatt and 8 kilowatts. Okay, if we look at the key features of the system, okay, so the system is IP65 rated, making it suitable for outdoor installation, flexible rate tariffs, okay, remote monitoring through application, okay, configurable AC and solar charging priorities via touch screen, okay, two channels output, the smart output and primary output. Basically, the smart output are those loads which we want to be disconnected at a certain battery percentage. For example, we choose 60% for this load disconnection. So at 60% the load, this kind of load will be disconnected, but the primary output or the primary load will be connected all the time and will be fed by the energy storage system. Parallel operation, so up to 6 units can be connected in parallel for enhancing the power for 6 kilowatt inverters. So if we connect six in parallel, so the maximum output power we can get is 36. It comes with a built-in Wi-Fi data logger for configuring with the home Wi-Fi and for monitoring purpose. The product appearance, here we can see a touch screen, okay, the status indicators, a DC switch, and the terminals for batteries, for from the power grid and load side, and for the PV panel. If we look at the screen, the touch screen, what we can see in that one, the PV information, the generation information, what PV generates, okay, the battery information, the grid information, and load side, like what how much load is connected to our system. Here we can see the main interface, the setting, and similarly the history. Here in the history we can see the alarms and warnings, the information of the system, and inverter mode, at what mode the inverter is working at that time. So these are some uh, icons which we can see in our touch screen. The next one is system configuration. Basically, the system has four basic components. The first one is the PV, the hybrid inverter, battery energy storage system, and utility grid. So we connect some loads to the system, which is off grid if it is connected to the inverter. If the load is directly connected to the grid, so that's on grid load. So there is no concern of the inverter or the energy storage system with on-grid loads. So it will only be responsible for off-grid loads. The product specification: rated output power 6 kilowatt and 8 kilowatt, which are the continuous and peak power ratings. Battery capacity ranging from 10 kilowatt to 35 kilowatt. Each battery module in this system is 5 kilowatt hour. The cell technology is lithium ion batteries. Efficiency is 93%. If we talk about the voltage, so that's depend on the uh, grid standards, which could be 220, 230, or 240. And similarly, if we talk about the frequency, it could be 50 or 60 hertz. The life cycle of the battery is 6000. Safety features: some hour current, over and under voltages, our temperature, okay, and some short circuit and overload protection. These are the integrated protection features of this system. Application scenarios for these systems are backup power, okay, energy independence, and cost saving. Parallel operation, as I mentioned earlier, so 6 units can be connected in parallel maximum. The capacity for the system will be the rated output power is 36 kilowatt, while the storage capacity will be 215 kilowatt hour. So next we'll learn some setting of the system. Here we can see the charging modes of the battery. Okay, basically in the charging mode we want to use the system, for example the PV generation and the power grid. So which one we want to prioritize for battery charging? Okay, either it could be a power grid or solar panel generation. So solar first, that means solar will be responsible to charge the batteries, and if solar is not available, so the power grid will be responsible. In case of solar and AC, both are responsible to charge the battery at the same time simultaneously. And solar only, in this case only solar will charge the batteries, solar generation will charge the batteries. And if the power grid is available, but in this case the power grid will not charge the battery at any cost. The load side, how we want to feed the load, either from the battery, solar panels, or from the power grid. So these are the priorities. Okay, so priority, for example, in case of AC, we give the priority to the power grid to feed the load. Then it could be solar panels and battery. In case of solar first, so the solar is responsible for feeding the load. Then it could be battery or power grid. And similarly for the battery first, a battery are prioritized to feed the load. Then it could be solar panel or power grid. Okay. In the priority setting, so for in this case, basically it is designed for those where the prices are not fixed. For example, during the peak hours the prices are higher, and during the off peak hours the prices are lower. So we can set the time, for example during the peak hours are from morning 8 to 10 p.m. So during this time, if the prices are high, so we use our energy storage to feed the load. But if the for example if the prices are lower from 10 p.m. to 8 a.m. morning, so in this time we feed the load and charge our battery. So we can use the battery energy during the peak hours. So these are for the settings of the charging and discharging of the battery. Okay, so next we learn the monitoring system of a low voltage energy storage system. Basically, here we can see the energy flow diagram of the system, the solar power generation, state of charge of the battery, the load power, and the power purchase from the power grid. Okay, if we move to the next, we can see a graphical representation for our power. Either it could be grid power, power generation, state of charge of the battery, or battery power. So you can see this one for a single day, for a month, for a year, okay, for a total time when we install our system. The next one, if we further move into the details, okay, so we choose the date and the time slot. In that one, we can see the rated output or generation power for the batteries, okay, uh, the battery voltages, the PV voltages, the power grid voltages. Okay, and also we can for the battery we can see the state of charge, state of health of the battery, current of the cells, and voltages of the cells. And the main thing is temperature for our energy storage system. The next thing is alarm for the system. If there is any alarm or warning or error in the system, so we can see here what kind of alarm is there. So here will be a list. So further moving into the fault and alarm. Okay, so what we can see, we can see the occurrence time and the type. Okay, and the description of that warning or alarm or error and description in here we can see the code for that alarm or error, and here we can see the status, either it is handled or not. Okay, on the load side we can set the output voltages and frequency, and similarly if we look at the energy storage machine setting, basically these are setting itself for the machine. Here is a case study for Hades series low voltage energy storage system. So there is a laboratory in Philippines. Okay, so they have installed a low voltage energy storage system. Here we can see the inverter and the batteries. There are four modules. Okay, so each module here is 5 kilowatt hour. So if we look at the quick facts, so the rated output power for the system is 6 kilowatt. Basically, the system is great tight battery backup system at this stage because the solar panels are not connected to the systems. If we talk about the storage capacity, which is 20 kilowatt hours, challenging address to the customer before installing the system for backup power. Okay, they require backup power, stable backup power, and there are a lot of power outage for that area. If we look at the future expansion plan, so we can add additional batteries and inverters in parallel, and also installing the solar panels. Okay. If you look at the payback period of the system, so for this system it's 6 years because there are no solar panels installed with the system, so it's only used for backup and during the power outage. The high voltage energy storage system, the series called Athena series. So the rated output power for the system are 8 kilowatt, 10 kilowatt, and 12 kilowatts. If you look at the key features of the system, so the system efficiency is 98.2%. Okay, load handling and backup capability. 110% continuous AC output overloading, 200% maximum backup output overloading for 60 seconds. Okay. The system supports 150% of the oversizing of solar panel. That means if we have an inverter which is 10 kilowatts, so we can connect 15 kilowatt solar panel to the system. If we look at the installation side and operation, okay, so it comes with that plug-in terminals for easy wiring, smart EMS that flexibly supports various operating mode, and OLED display and application for setting and data management. Next, we look at the appearance of the system. Okay, so here we can see the LED display. Okay, the grid status indicator and communication indicator. Here is the action button. Basically, the grid status indicator shows that either the system is connected to grid or not, and the communication shows that is it communicating between the BMS battery management system and the smart meter connected to the system. In the LED display, we can see some parameter for different For PV could be grid battery. So here is the battery parameter. So the battery voltages, discharging power, the battery percentage, okay, and the signal strength with the home Wi-Fi. Next is system configuration. Okay, again, basic component for the system are PV, battery energy storage system, hybrid inverter, and some backup load and power grid. Okay, so basically this system can connect to a smart generator, which can sense the signal if the system can send the signal to the generator, so it can sense, and some other smart loads like heat pump and other smart loads, and the on-grid load which is directly connected to the power grid. System specifications: rated output power 8 kilowatt, 10 and 12 kilowatts, which is a continuous and peak power ratings. The battery capacity ranging from 10 to 25 kilowatt hours. So in this case, the battery module size is 2.56, and for this one, like from 20 kilowatt hour to 30.7 kilowatt hour, the module capacity is 5.12 kilowatt hour. And the technology is again lithium ion batteries. The efficiency is 98.2%. Input and output voltages and frequency. So the system is a three phase. So it could be 380, 400, or 415, depending on the grid standards. The frequency 50 or 60 hertz. The life cycle for battery is 6000 cycle, and the safety features again DC reverse polarity, surge protection, ironing protection, and other protection like over temperature protection or short circuit protection. So maximum 10 units can be connected in parallel. So the maximum power rating can be 200 kilowatt and 614 kilowatt hour. Product key features: intelligent load access with the flexible settings, integrated ground fault circuit interrupter for safety, fast shutdown capability. Basically, fast shutdown capability means it comes with the emergency button. So in case of emergency, so we can use that button to shut down the system. 110% three-phase unbalanced output for phase A, B, and C. 110% continuous AC overloading support for the system in case of off-grid, up to 120% overload support. And if we talk about the switching time, so it's less than 10 milliseconds, which is uninterrupted power supply switching. Some product parameters. Okay, the product models comes with the company name. Okay, the series, and XK represent in XK. X represents the rated power of the system, and P3 is the system is three phase. So the maximum PV input power is 150% of the rated power of system, as I mentioned earlier. The startup voltages for the PV and battery is 135. Charging and discharging current is 25 ampere. Rated AC voltages, it could be 380, 400, and 455 depending on the grid standard. And similarly, the frequency, which is selectable again, and number of MPPTs. So there are two MPPTs for this system. Okay. The monitoring system of high voltage energy storage system, there are three kinds. The first one is cloud based. The second one is cloud monitoring application for the mobile phones, and the third one is local configuration application. So basically, these are used for remote monitoring and configuration, and this application is used for local monitoring and configuration. Here are some setting parameters. We can see the energy flow diagram, PV information, battery information, grid, and load information. So the working mode of system, rated power of the system, and the battery connected to system. Similarly, if you move to the parameters, we can see multiple parameters like for the PV, battery, for the inverter, backup load, on the grid side, and the some grid parameters. In batteries, we can see the state of charge, state of health, voltage, current, and temperature. Next, moving to the settings. So here you can see the quick configuration. So it could be the operating mode of the system, some basic parameter, other power control, and maintenance. In maintenance, we can remotely control our system while we can turn it off, or we can restart our system if it is required. Some other settings for the protection, for voltage protection, the maximum and minimum and maximum voltage. Similarly, for the frequency, minimum and maximum frequency, and the time. And for example, if it detects the protection threshold value, so when it should be disconnected, how long it should take. For example, it's 1.6 seconds. Battery parameters for on-grid and off-grid SOC protection. So we choose 20% for both. It could be 10%, 15, or 20, 30, any value. For a period setting, so we choose the timing for charging and discharging our batteries. Okay, so it's again for the uh, peak and off-peak timings for like peak and valley prices. So the next we will learn the installation requirements. So in installation requirements, so if whenever we install the system, so there must be uh, at least 50 centimeters on either side, spacing on either side. The altitude is 2000, the temperature operating, which is minus 15 to 55, and humidity is from 0 to 85. If we talk about the grid environment, so should check the grid standard with the system. The distribution box wiring in case of single or three phase. In case of three phase, we have to check the phase sequence, and there should be no leakage or short circuit on the load side, and we avoid disorderly wiring in the distribution box. And for installation, there must be some certified and professional technician or electrician for a system installation. So here is the case. The system installed in the Finland. The system is 15 kilowatt. The energy storage is 30 kilowatt hour. So the system size is for the PV is 14.6, or each PV module is 430 watt. The storage capacity 6 modules. Each one is 5 kilowatt hour. So the total is 30 kilowatt hour. Cost saving on monthly bill is up to 75%. So the challenging address for the customer before installing the system were like the energy prices were very high and very dynamic. Okay, and this installation type is roof type installation. For the PV panels, if we talk about the expansion of the system, yes, this is we can add additional batteries and inverter to maximize the power and energy storage. And if we talk about the payback period of the system, so for this system the payback period is 3.2 years. Now we will learn about the commercial and industrial energy storage system. Uh, Basically, commercial and industrial energy storage system is a type of user-side energy storage designed to optimize energy management for businesses and industrial facilities. So, energy management system basically in energy management, we store energy during the off-peak hours and use it during the peak hours. Renewable integration, so we use some renewable energy sources to generate energy. Grid supports, in this case, these commercial and industrial energy storage system provide services to the grids, for example, frequency regulation and voltage control to maintain grid stability and reliability. The backup power, in case of power outage, we can use it as a backup power, safeguarding the critical business operation. Scalability, so yes, these systems are scalable. For example, we have installed a system, so we can install another system to scale the present system. The application scenarios, so we can use this system for EV charging stations, for islands, generation of electricity and store them. Okay, for commercial buildings and shopping malls, for some hospitals, data centers, farming lands, and wind solar generation plants. If we look at the application modes of the system, so the first one is peak shifting or demand charge management. Basically, these are used to reduce energy cost by storing power during low demand period and using it during peak times. The customer's self-supply enable customers to generate and use their own solar power, reducing dependence on the power grids. Can work as a microgrid, support small-scale independent power networks for communities or facilities. Backup power. So in this case, the system provides reliable power during grid outage to keep the essential applications running, appliances running. So we have divided the commercial and industrial energy storage system into three parts. The first one is small scale, medium scale, and large scale. So basically, there are three standard energy storage system for Magic Power. So we will learn one by one. The small scale is the series called Titan. The battery capacity ranging from 63 to 105. The battery technology is lithium ion batteries. Rated output power is from 25 to 50, which is a continuous and peak power rating. The efficiency of the system is 98.8%, and output and input voltages, depending on the grid standard, either it could be 380, 400, and 450, because these systems are the three phase cycle life of the battery, which is 6,000 cycles. Safety features for the battery, it can be overcharging and discharging. Okay, the short circuit on the load side or overloading, and thermal management for the system itself. The applications for these systems are used for backup power, peak shaving, and renewable integration. So in parallel, we can connect three units. So the maximum system capacity is 150 kilowatt hour. 150 kilowatt is the rated output power, while 316.2 kilowatt hour is the energy storage for Titan series. The next one is medium scale energy storage system. So the series called Taichi, the battery capacity is 215 kilowatt hour. Cell technology is lithium ion batteries. Rated output power of the system is 100 kilowatt, which is a continuous and peak power rating. Efficiency of the system is 97.3. The voltage, either it could be input or output. So again, the system is three phase, so it could be 380, 400, or 450. The life cycle of the battery is 6,000. Safety features again for the battery side, so overcharging and discharging. For load side, short circuit, overloading, or our currents. For the system itself, is a thermal management for the system. Application or use cases, it's again for backup power, peak shaving, or it can be for renewable integration and grid services. Parallel operation of the system, three units can be connected in parallel. So the maximum capacity or rated output power is 300 kilowatt, while the energy storage is 645 kilowatt hour. The third one is Titan Plus. Basically, this one is a large scale energy storage system. The series called Titan Plus. The battery capacity in this case is 1 megawatt hour, which can be customizable, can be more than this. Okay. The cell technology is lithium ion batteries. The rated output power for the system is 500, or it can be customizable according to the requirement, which can be a continuous and peak power ratings. The system overloading capability, if it is overloaded for 110%, so then it will run up to a maximum of 10 minutes, and in case of 120% overloading, so the system operation time will be reduced to 60 seconds. The input and output voltages, the system is again a three phase, so it could be 380, 400, and 415. The life cycle of the batteries uh, is more than 6,000 cycles at 80% of depth of discharge. Safety features or protections, so again for the batteries we have overcharging, discharging. For load side, it can be overload, short circuit, and work for the system itself. It's the thermal management. So there are other integrated protection in the system. An application cases for this energy storage system can be used as a microgrid, or can be used for grid services. It could either be used for backup power, peak shaving, and renewable integration. So basically, the series is all in one unit. So next we look at what main components we use in the system for the safety or for operation. Okay, some sensors or some protection system for the system itself. So the system components includes the emergency power off button, transfer switches, energy management systems. How
Now
do
we
we
learn
manage the
about the commercial
energy
and industry
which is
energy storage
stored or
system.
which we want to buy from the power grid or the solar power generates the energy. Similarly, the battery modules, high voltage box, some switches for solar panels, power grid, and load side diesel generator terminals. So, if you talk about the sensors, so the system is outdoor, so it has a water immersion sensors, and the cooling system for these are is air cooling system, fire protection system, smoke sensors, and door lock and unlock system. Sensors are installed in the system. So next we will learn some case studies of commercial and industrial energy storage systems. So here is an auto dealer. We will look at the quick facts of the project. So the total system size is 100 kilowatts. So the solar panel installed are 182. Each one is 550 watts. The storage capacity is 215 kilowatt hour. The estimated annual output is 104 megawatt hour. While the challenges addressed to the client before installing the project were like the grid was unstable, power outage, and the energy cost was very high. The installation type of the solar panels are roof type. Here we can see the future expansion. Yes, additional batteries can be added to the system, and the payback period for the system is calculated, which is 5 years. The next one is container size. So it's a 40 feet containers for an off-grid EV charging station in South Africa. So the quick fact for this projects are the total system size is 316 kilowatts, which is the solar panels capacity. So each one is 580 watt. So the total number of solar panels installed for this system are 545. The storage capacity 558 kilowatt hour. Estimated annual output for the system is 475 megawatt hour. So if you talk about the installation environment of the solar panels, so they are ground mounted, and the future expansion, yes, the system is designed customizable, so we can add 500 kilowatt inverters and up to 1 megawatt or energy storage system. And the payback period for this system or this project is 8 years. The next one is cold storage enterprise. If you look at the quick facts of the project, so the total system size is 500 kilowatt, and the number of solar panels installed in these projects are 910. Each PV module is 550 watt. The storage capacity for this project is 1.5 megawatt hour. Annual estimated output for this system is 365 megawatt hour. If we talk about the challenges addressed to the client before installing the system, like the grid was not stable there, the power outage was a big issue, and high energy cost. Uh, the installation type of the solar panel you can see in the pictures, the rooftop and carport. In future expansion plan for this project, yes, additional batteries can be installed with the energy storage system to enhance the storage capacity. It can be integrated with other renewables, and calculated payback period for this project is 7.5 years. So thank you everyone. It was all about the portable, residential, and commercial industry energy storage system. Thank you everyone for listening. Thank you very much.